We've already learned how to solve equations when there's only one operation, and that was to make sure that you understood that whenever we want to move a number to the other side of the equal sign, we have to do it by doing the opposite of what it's currently doing. But when we are solving equations that have more than one operation, then it's important that we do those operations in the correct order, much like solving or simplifying an expression by using order of operations. So basically what we are doing is we are undoing the order of operations, which means in order for us to get that one thing by itself, because solving equations just means you're isolating one thing. So to get that one thing by itself, you need to work backwards of the order of operations. So remember, order of operations says parentheses, exponents, multiply and divide from left to right, and then add, subtract from left to right. And so when we're solving, we are going to do that in reverse. So we are going to get rid of addition and subtraction. We are going to get rid of multiplication and division, and then we would get rid of any exponents, and that would free up any parentheses so that then we could go back up and then start working through the steps again. And while we're not going to do any that are super complicated, it's important for you to understand that in solving, it is just the order of operations in reverse. So let's just write this over on the side so that we remember what we're doing. So we're not really going to have any parentheses to worry about, but we are going to do some two-step, and there could be some distributive property, which is another way that you can deal with those parentheses. So if we had just a regular two-step equation, then we would have 2x minus 1 equals 15. So according to this, we've got two operations. We've got to multiply and we've got to subtract. And our rule is always going to be to move the thing that is being added or subtracted to the variable. So it's super important that we pay attention to which term has the variable, because it's going to be the last one that you deal with as a number that's with the variable. So here I am going to add 1 to both sides, because that's going to zero out that addition or subtraction. So now we've got 2x equals 16. And notice how I'm keeping everything lined up underneath what it's going to be impacting. Then for our next step, now that there's no addition or subtraction left for us to move, then I'm going to go ahead and I am going to divide by 2, because that's the opposite of the multiply that is implied in 2x. And then that's going to give me, that's going to not zero this out, but it's going to make it equal 1. So we've got 1x. So I've got x equals 8. And then if I wanted to check it, I could just go ahead and I could say 2 times 8 minus 1 equals 15. 2 times 8 is 16. 16 minus 1 is 15. So I know that this is my correct answer. And that's the nice thing about equations, is you can always plug them in to check them. So another option that we could have is we could have that fraction. So another common one. We don't see divide very often in multi-step equations. Usually it's going to be in a fraction form. So for example, if we had 1/2 x plus 3 equals 6, then that would be the same as x divided by 2, because 1/2 times x is the same as x divided by 2. So usually we will see the division in its fraction form. So again, we're going to get rid of any addition or subtraction first. We would subtract 3 from both sides, which would leave me with 1/2 x equals 3. And then I would multiply both sides by the reciprocal. And the reciprocal of 1/2 is 2 over 1, which is the same thing as just multiplying by 2. And so that means that I am now left with x equals 6. So that's how we would do that. Most of the time you're only going to have two-step equations. There might occasionally be times where you would combine two terms on one side of the equation before you actually start solving. So I'll just show you a quick version of what that would be. So let's say that we had 2x plus 1 minus x equals 5. So because these two terms are on the same side of the equal sign, I would want to combine them first. So 2x plus 1x means that I am just going to have 1x plus 1 equals 5. And this 1 can become invisible because remember there's always that invisible 1 in front of x. So I'd subtract 1 from both sides and I would be left with x equals 4. So remember, anytime the terms are alike on the same side of the equation, so on the same side of that dividing line, then we're just going to add them together and simplify it first so we have fewer terms that have to move to the other side of the equation. So the last thing that I wanted to show you is if there are variables on both sides. So for example, if we have 4x minus 5 equals 2x plus 3, and I want to solve that. So this is a pretty common scenario. So the important thing I find to make it easier is to move all of your x's to the same side of the equation. And it doesn't matter which way you move them, so I always try to move them in a way that will keep the coefficient positive. So remember, coefficient is that number in front of x. So if I were solving this one, we've got our little dividing line. Oops. There we go, our little dividing line. If I were going to solve this, I would move the 2x over to join the 4x because I could do that by subtracting. And if you're not sure, then you want to remember that if there's no sign in front of it, this is a positive 2. And so the opposite of a positive 2 would be a negative 2, which means that we would subtract it. So we're going to subtract 2x from both sides. That's going to leave me with 2x minus 5 equals 3. And now it's just a two-step equation like we just did before. So I'm going to go ahead and I'm going to add 5 to both sides, which leaves me with 2x equals 8. And then I'm going to finish by dividing by 2 to get x equals 4. And then if we wanted to check it, we absolutely could. If we said 4 times 4 minus 5, so, oops, don't need that parenthesis. It gives me 16 minus 5, which is 11. And then 2 times 4 plus 3, which gives me 8 plus 3, which also is 11. So that lets us know that we solved it correctly. So if you're not sure if your answer is correct, always feel free to plug it back into the original equation and do the calculations using order of operations, and you'll be able to tell if you solved it correctly. And if not, go back and rethink through the steps that remember we get rid of addition or subtraction first, and then multiply, divide, and then that should free up any parentheses that may be in there if you didn't use the distributive property to get rid of them. And then if there are x's on both sides, your first step should always be to get the x's together on one side.